Okay, so we are talking about adding and subtracting polynomials. And so before we can get into the actual operations, we need to make sure we are understanding some of these vocabulary terms. Okay, so the word term, it just refers to when we're talking about mathematics, it just refers to a constant or a variable or a combination of constants and variables, right? So a term, it can be anything like x, it can be the number 7, it could be 7x, it can be 7x to the second power, so on and so forth, right? But that is a term. A monomial it's a special term, but it's just, it's just one term. Okay, so it can be any of those same numbers or terms that I've just listed above, or it can be a combination of 7x squared y. It can also be 2/3 y to the fifth. It can also be 4, right? All of those are monomials. A polynomial, that just means many terms, right? So that just means many polynomial terms. Binomial means two. Okay, so a binomial would be 7x plus 3. Okay, and a trinomial means 3. So it would be 7x squared minus 6x minus 4, right? Where all of three of these terms are different and we can't combine them because in order to combine these, we would need to have the same variable and the same power or exponent. Okay, a coefficient is just the number that's in front of the variable. Okay, the variable is, the unknown value that we don't know, usually represented by letters like A, B, C, so on and so forth. Um, the degree of a term is to what power is the term raised to, right? And so if we was looking at this trinomial, we would say it has a degree of 2, right? That's the largest degree in the terms. Okay, so that's what's answering that third one, the degree of a polynomial. Okay, descending order is what it sounds like. You put it in order from biggest to lowest. The leading coefficient is the biggest coefficient of uh, of your terms to the highest power, right? So if we had, let's say we had 8y to the 6 minus 7x to the fourth plus p to the eighth, right? The leading coefficient would be 1 because p has the highest power. Okay, like terms is what it sounds like. The terms are alike, like everything matches. The variable, the power, the combination of variables or powers, they all have to match. And unlike terms is, this trinomial, that is three unlike terms we could not combine. All right. So now let's look at adding and subtracting these polynomials. And so this first one is negative 8x plus 10x. And so, our variables are the same. So we can just take these coefficients and add them together, right? So negative 8 plus 10 or 10 minus 8 is going to give us 2. And we have an x on the end. So we're not multiplying. So it doesn't become 2x squared. When we're adding and subtracting, you simply just rewrite the coefficient. I'm sorry, the variable. It's almost like when you're adding and subtracting fractions, the denominator remains the same. You don't add the denominator or subtract the denominator. Okay, so looking at question 2, same thing. I have x to the second power. Okay, so I have negative 6x squared minus 20x squared. So if my signs are the same, I just add them together and keep the sign. So that just becomes negative 26x squared. Okay, so question 3, don't let one like this fool you, right? So we have an x on the 6, we have a y attached to the 3. These are unlike terms, therefore we can't combine them. So the final answer would just be 6x minus 3y. All right, so as we move into question 4, negative 9a to the fourth b to the third minus 2a to the fourth b to the third. So my variables and powers are the same. So I just take my two coefficients. Since they're both negative, I'm going to add those together, keep the sign. and it's a to the fourth, b to the third. All right, and so lastly, when we get a long polynomial, we just got to combine like terms. So it's probably a good idea to rewrite this to where your terms, your like terms are together, so you know what you're looking at when you're combining. So this would be, if I rewrote this, this is 9x cubed minus 4x cubed minus 3x plus 2x plus 5. Okay, and so now I can combine. So my coefficients is 9 minus 4 is going to give me 5x squared, or I'm sorry, x cubed. Negative 3 plus 2 is just going to be negative x plus 5. And now we are as simplified as we can be. Okay, so the descending order is that, you go from your highest degree in the polynomial and then just go smaller from there. Take it to the smallest terms from there. All right, so when we are looking at questions like 6, 7, 8, and 6 through 10. Okay, so again, we have quite a few quite a few terms that we're trying to combine, right? So it's a good idea to, I know you can't probably always use different colors, but you can probably draw like shapes so that you know what is alike and what isn't alike. So when you go to combine, you know what it is that you're combining. All right, so if you have to rewrite it, just go ahead and rewrite it. X cubed minus 2x cubed plus 3x squared minus x minus 3x plus 3 plus 4. Okay, so I can combine my cubes, my x cubes. So 1 minus 2 is just negative x cubed. Nothing's alike with the 3x squared, so I just bring it down, plus 3x squared. Negative x minus 3x is just negative 1 minus 3x. They're the same, so keep the sign to add them. And then plus 7. And again, those are already in descending order from the highest polynomial degree. Looking at 7. So if you notice, like, okay, 0.33x squared is by itself. I can't combine that. And then I have negative 0.2x, negative 0.3x, and positive 0.14x. So just think of cents, right? So this is 20 cents plus 30 cents. I'm saying plus because the signs are the same. So that's going to be a negative 50 cents and then plus 14 cents, right? So I got negative 50 and it's adding to a 14. So when my signs are opposite, I just subtract and take the sign of the biggest number, right? So this would be negative 0.36x. I'm about to write a z when it's an x. And then lastly, you have a negative 1 plus 10 cents, right? So this is just going to give me a negative 90 cents or 0.9, right? Because think of a dollar. It's a negative dollar. So, and I'm adding 10 cents. So when my signs are opposite, this is a negative, this is a positive, I just subtract and take the sign of the bigger number. 1 is bigger than 0.1. Okay, so 8's a little trickier because, 6 and 7 have been plus. 8 is subtraction, right? So you got to imagine that this is an imaginary 1 and it's going to distribute into every term in the parentheses. Okay, therefore, this term becomes positive 2x to the third plus 3x plus 4, right? Another way you can see this written sometimes is you can just take the other polynomials or the other terms and just put them right under. So since there's nothing alike with the 3x squared, I'm going to just throw that on the end. minus x plus 3. And now I can combine my like terms. 2x cubed plus 1x cubed is 3x cubed. To keep this in descending order, I'm going to just bring my plus 3x squared on over. Plus 3x squared minus x plus 3. And we will be done. Okay, same thing with question number 9. Because that, it's this trinomial minus this trinomial, I have to distribute this -1 into all 3 of these terms. So that becomes a negative 4x squared, a positive 3x, and a positive 3. And again, I can just bring down my terms over here. So positive 6x to the 4th plus 3x squared, and then minus 1. And then when I go to combine that, I'm going to get 6x to the 4th minus x squared plus 3x plus 2. And we will be done. And then lastly, number 10, same thing. I'm going to distribute this -1 into all 4 terms. So we get negative 5x cubed plus 4x squared plus 3x minus 3. And then I'm going to bring over the 4 terms from the first polynomial. So we get x to the 4th plus 5x cubed plus x squared minus 1. And then when I go to combine these, I'm going to get x to the 4th. And so negative 5x cubed plus 5x cubed, that's just 0, right? So it doesn't matter what the x is. Once you cube it and multiply it to 0, it's still going to be 0. So then we can just say, okay, plus 5x squared plus 3x minus 4. And then these last two is just making sure you're reading these correctly. It says subtract 6x squared minus 3x plus 9 from, right? So we're basically going to rewrite this to where the 3x squared plus 7x minus 3, and then we're going to subtract the 6x squared minus 3x plus 9, right? So now we got to distribute negative 6x squared plus 3x minus 9, and then put our like terms underneath that we're going to combine with this. Okay, so we get negative 3x squared plus 10x minus 12. All right, and the last thing, or the last one, question 12, fairly similar. Okay, so we're going to say negative x minus 6 minus x minus 6, which becomes negative x plus 6, and then negative x minus 6 underneath. So I'm just going to get negative 2x, and these cancel, right? So that would be our final solution. Okay, so hopefully this has been helpful for you as you continue to work through this module. Just remember, it's important. Like, we're not going to have a quiz on making sure you understand these terms. It's just some of the way that the questions are phrased that you'll give yourself a better chance if you're understanding what it is that you're being asked. Okay, if there's still anything you need clarity on, do not hesitate to reach out. Talk to you shortly.